Recording, I forgot to record. Just a remind every day.
Okay, sir.
Okay. This is you have to between mirror and F, behind the mirror. It is enlarged image, erected, and virtual. Next on focal point, the image at infinity. This is not enlarged. This is completely pointed image. Between F and C, B and C, enlarged, inverted, real. Okay, this we have to remember. This is very important one. Now next coming to next ray diagrams of next. This is about complete ray diagrams. Up to ray diagrams for concave mirror we completed. Ray diagrams for concave mirror we completed. Now ray diagrams for convex mirror we are going to observe. Okay, ray diagram. Okay, concave mirror. What is the use of concave mirror? We will discuss. Okay, it is using as a shaving mirrors. It is actually images seeing. We are seeing big images on this. We have a dentist also observing the teeth by using this. Because of that reason, we are using in dentist. We are called as dentist mirrors, shaving mirrors. Okay, especially these concave mirrors for making image large. To see the big images, we are using this concave mirrors. Concave mirrors. Now, some more examples are there on this. Some more examples are there on this. Okay, some more examples I will show you. Okay, this is the how the he explained.
Hi friends, if you hi friends, if you stand in front of a plane mirror, do you know exactly where your image will be found? That's right. It will be behind the mirror. The distance between the image and
Are you getting the sound?
No, sir.
Okay, no problem. Sound is not required. The image is forming behind the mirror. Why? Because here to make the image, they are applied aluminum coat behind this mirror. Behind this mirror, they applied aluminum coat. Because of that reason, they applied aluminum coat. Because of that reason, this is the plane mirror image is forming behind the mirror. Okay, next one. Okay. See, this is the virtual image. 1 second. Hello. Okay, this is the image. See, this is the only in the. Hello, Vignesh, are you there? Okay.
Yes, sir.
This is the image is virtual upright image, same height image we are going to see. Virtual image. This is not the screen. We are seeing in the plane mirror. We are observing in the plane mirror. Okay, we can't take on the any screen. Okay, this is the convex mirror. Inside is rough surface, outside smooth surface, reflecting surface, bulged outward direction. Okay, now next one is the image. Okay, this is the object. Here two rays are coming and reflecting back. When smooth surface is there, reflecting arrow marks you can observe here. On the plane mirror, arrow marks you can observe here. How the image is falling is explaining. Next one. Now principal axis, he has taken principal axis, pole, focal point. He has taken principal axis. He kept the image. What is this image? What is that mirror? This one. This is the concave mirror. This is the concave mirror. This is the concave mirror. Okay. Now next in this concave mirror, see he is observing. He is in the concave mirror. Okay. See, this is the rule. What is the rule? He has taken as a, he told as a rule one. Rule one, parallel axis passing through focal point. This is rule one. This is he told as rule two, passing through center of curvature, reflecting back. This is the rule. What is the rule three? Rule two actually, I told rule two, he told rule three. Little bit variation, that's it. Passing through focal point becomes parallel. This is the rule two, and incident angle equal to reflected angle. Rule four. Did you understand?
Yes, sir.
Just I am revising this, all those things. Okay. Next term. Now next one, next is going to draw the rule 1, rule 2, rule 3, rule 4. Rule 1, parallel ray going through, passing through, after reflecting, passing through focal point. Next term, the ray passing through focal point, it becomes parallel, rule 2. When the ray is passing through center of curvature, then reflects back, rule 3. Next term, incident angle equal to reflected angle, rule 4. Next term, now he is the object. He stood behind the center of curvature. You see, he released one ray that is passing through focal point. Another ray is passing through center of curvature. Object kept between B and C. Image formed between F and C. B and between. You should remember the keyword. B and. When the object kept B and, image formed between. Image formed between. B and F, object kept B and C. Image formed between F and C. Did you understand? See, the object, the person is completely reverse here. Head is down. The person is completely reverse here. Head is down. Legs are up. Are you seeing image? Okay.
Yes, sir.
The person is released for two rays. One is passing through focal point. Another one is passing through center of curvature. The both incident images here. The head is down. Legs are up. This is what? Inverted image. Inverted image. Okay, this is diminished. When object kept B and C formed between F and C, the image is decreased size. Next one. Now, this is okay. Properties of real and inverted and virtual upright, magnified. Okay, here in the case one, here image what happened? It is real and inverted image. It is real and inverted image. Okay. Now next he moved. He walked and moved on the sea. He walked and moved on the sea. He stood on the sea. Okay. The ray he released is passing through focal point. When object kept on sea, object kept on sea, image, object kept on sea. On sea, image also formed on sea. Image also formed on sea. That is also same size of object. Hello. Vignesh?
Yes, sir.
Okay. Object kept on sea, image formed on sea, same size of object you are going to observe. Okay, next one. Object kept on sea, image formed on sea. Real, inverted, same size at sea. Real, inverted, same size at sea. Okay, real, inverted, same size. Now he went to between F and C. Between F and C. See, one ray is passing through focal point, another one is passing through focal point. See, this is the image is enlarged image. Enlarged image. Real, inverted, and between F and C, B and C. Enlarged image. The person is small here. Here, big image we are going to observe. Enlarged image. Enlarged image. Now, object kept on F. Object kept on F. Now here, it is a parallel rays are forming. Okay, this is real inverted image. Image is not forming. It's an infinity image. We are seeing that image at the sun. That is the sun is the example for this. We are unable to see the image. Object kept at F. Image at infinity. F మీద పెడితే infinity దగ్గర image form అవుతుంది. Okay, next one. Object kept between F and P. Here, behind the mirror, image is forming. That is virtual image is forming behind the mirror. The very big image, enlarged image is forming. Enlarged image. Okay, this is between F and P. Now, how the concave mirror is used? Shaving mirror. Now convex mirror. Now coming to convex mirror. Pole, focal point and center of curvature. Now, rules for same rules again. When object C. Now for convex mirror. Now for convex mirror. Okay, this is the reflecting surface. This is the reflecting surface outside. Rough surface inside. Reflecting surface bulged outwards. Okay. In the last case, what happened? Smooth surface is inside. Rough surface bulged outwards. Here completely reverse. Rough surface inside, smooth surface outside. When the ray is falling on the mirror, actually the imaginary ray, whatever the ray, imaginary ray, behind the screen it is happening. It is falling at the focal point. Then image it is what happening? Then image is, then it is, then it becomes parallel. Okay, when the ray is falling on the convex mirror, when the imaginary ray meeting at the focal point, after reflecting, bounce back in as a principal axis. Okay, this is one law. Next two. Okay, when the ray is incident on the pole, then it is reflecting with the same angle. Here incident angle equal to reflected angle. Incident angle equal to reflected angle. Here see when the ray is passing through focal, imaginary ray passing through focal point, then it reflects back. So sorry, when the ray is parallel to principal axis, after reflecting it is bouncing back. It is meeting at the focal point. This is rule 1. What is the rule 2? When the ray is passing through center of curvature, this is the inside one, imaginary. It reflects back. It is outside, it is happening completely. Okay, here when the ray is passing through focal point, then it reflects back. This is the rule 4. When the ray is passing through pole, incident angle equal to reflected angle. Did you understand this all? This is the rule.
Yes, sir.
Rules to convex mirrors. This is the rules to convex mirrors. Here all imaginary. We are imagining inside the mirror it is happened. We are imagining actually this all those things. Because of that reason, he made a lines, dotted lines made. Dotted lines made because of that reason. These are the imaginary lines. This is happening outward the reflecting surface. These are happening on the reflecting surface, outside reflecting surface. Okay. Here, in the 2 minutes, coming 1 minute, meeting will be over. Again, I will post the link. Again, you click. Again, join again. No problem. Okay, this is the rule 4. Now, ray diagrams we have to do for this. Ray diagrams we have to do for this. Ray diagrams. Okay. Okay. Object is, this is the pole, focal point and center of curvature. Okay, see, parallel ray is releasing out. It is meeting at the focal point. One more ray is meeting out. One more ray is releasing. That is reflecting back. ఇది ఎక్కడ కలుస్తుంది? సి దగ్గర కలుస్తుంది. ఇది రెండు మీట్ అవుతుంది. Object kept where? Object kept image formed between. Object kept B and C. But image formed between P and F. B and C. Object kept between P and F. Object kept between P and F. That is virtual image. Now object kept here. Now we will go for this one. This is the rules. Rule 1. Parallel ray, imaginary touching at focal point here. Next, parallel ray, The ray passing through focal point, it becomes parallel. The ray is passing through center of curvature, reflects back. Now here object kept here. Two rays are object where behind the mirror it is formed. Here the rules for this. For this box he may not give, I think. For this box he didn't give. Okay, the image is completely only one ray diagram is there here. Okay, object kept behind the mirror it is forming. Behind the mirror it is forming. Object placed at any point on principal axis. Okay, hence this is the virtual image it is forming. Okay, so image object is placed at, note down here. Now here diminished image we are going to observe. Erected and diminished image. Size is decreased, diminished and virtual image between P and F. AB is the object placed at any point on the principal axis, but in front of the convex mirror, but image is formed between P and F. Only one ray diagram is there for convex mirror. Only one ray diagram. Only one ray diagram is there for convex mirror. Now next one is derivation formula for curved mirrors. Derivation formula for curved mirrors. Okay, now derivation formula for curved. How to derivation formula? Mirror formula is 1 by F is equal to 1 by V plus 1 by U. How this formula came, I am going to explain. Derivation formula for mirrors. 1 by F is equal to 1 by V plus 1 by U. How this is called mirror formula. 1 by V plus 1 by U. How this came, I am going to explain now. Okay, this is object kept B and C. Object kept B and C. Okay, here two rays are released here. Two rays are released here. Okay, one is passing through focal point. One more ray also released. It is passing through center of curvature and reflecting back. Image is formed where B and C. Object kept B and C. Object kept B and C. Image formed between F and C. Between F and C. Image formed between F and C. Now from here, image formed between F and C.